Hello. Hi, Rohi.
Hello.
Hello. Give me 1 minute, Rohi. I'm just preparing the system. Then we are going to start. Yeah. Okay. Um, I think we can make a start. So I will be downloading the data later on. So let's give it a start. What I would do is that let me just give me 1 minute, Rohi. I'll just share my screen. I'm just opening the notebook where I need to write things first, and then we can give it a start. Uh, so yeah, so this whiteboard. It's a bit slow today. Not sure why, but this would work. Should work. Yeah. Okay. Okay. Sarangs is joining in as well. So yeah. Okay. Okay. Uh, Whiteboard. Sarangs, can you hear us? If you can just
Yes,
quickly
Soumya.
confirm. Yeah,
Yes, yes.
great. Okay, so let me just share share screen, Microsoft Whiteboard, and share. Uh, can you confirm now that you are able to see my screen?
Yes.
Okay, okay. I hope the same is there for you, Rohi. I'll just do some drawing and see. Okay, so yes, so you can see my screen. So let's start with the with a session. Just a quick note, as per our plan, what we had to do is that we have completed introduction to machine learning. We have looked into single and multiple linear regression. Next, we have looked into logistic regression. Further, we had to look into linear discriminant analysis and clustering. But linear discriminant analysis and clustering, or even at later stage we will look at PCA, which are dimensionality reduction or unsupervised learning problems. Please don't worry about those words, we will come back to them, but as of now let's skip them because we're into this supervised learning mode. So let's continue with that mode itself, right? Let's go ahead with the supervised learning algorithm first. Once we finish them, we will come back to them. Okay, so we will come back to the unsupervised learning ones, including the clustering ones, right? So what we are going to start as of today is related to a technique which is really very easy, really very simple. It will not take much time to understand what is going on, and also it will be very easy for you to see why this method is most preferably, okay, most preferably one of the most common business methods, I would say, which are used to explain cases. Okay, cases where we can clearly do some form of let's say bifurcation. So for example, I'll take an example and then we'll understand. So example is, let's say I have some data, okay, which is related to how children, okay, this is a children, these are just 3 or 4 children who are living nearby, let's say, okay, and uh, they would like to go out in the ground to play. Okay, we are going to take a very small example right now, and later on we are going to take more examples. Okay, so we need to do some extensive set of examples here, because one example from this time onwards is not going to help. So that's why I might be going a bit speedily when I do the coding part, because we have already done one set of coding part, right? So I don't need to pause at each and every point in time, I hope. So what I'm going to do, I'm going to increase my speed so that we can cover more of use cases, so that we can do projects, right? So the example, let me come back to my example. So my example is related to these children who would like to play, right? Now what I have as a data to solve their problem is, they have a question, and the question they have is, whenever they go out to play, sometimes uh, it the wind is strong, okay, maybe the humidity is high, even the outlook, okay, the forecast is actually sunny, right? So is that really the right environment for them to play? Because if they go out, many a times what happens is their parents are getting angry on them, or their parents are really getting concerned about them. They're getting angry because they're concerned. The reason being, if they're going to play in not so suitable environments, that is going to impact their health, right? So now they have a problem. This is their question. So always in any data science problem, we start with a question in mind. So now the question here is, given a set of conditions, can they play? Is what the problem is. So what we have is that, let's say, um, I don't know how I can move this. I don't know. No, let me just move the scale out of the picture. So I have a data set where I have captured, let's say, the last 14 days. Okay, the last 14 days. So there are 14 rows over here. 1, 2, 3, and so on. Until 14, I have 14 rows. And I have 14 days, last 2 weeks of data, related to what kind of conditions were there outside, and whether they really could play or not without impacting their health. So my target column, okay, or my target variable, okay, is going to be whether they were able to play or not. Okay, so whether they were able to play or not. So let's say for some days they were not able to play, and for some days they were able to play. So let's say for the first 2 days they were not able to play, but for the third day they were able to play. Okay, now the features, okay, the data that I have is, first of all, I have the outlook in the sense whether it is sunny outside. So I'll write S for sunny. If it is sunny, I'm going to write S. It is overcast, I'm going to write O. And if it is raining, let's say on the 14th day, it was actually raining. So I'll write R. Either it is sunny outside, or it is overcast, okay, or it is raining. Okay. So after 3, there are a lot more rows over here. Okay, I'm just skipping those rows. So let's say they are, or maybe I can take an Excel also. So, or yes, of course, I'm going to download the data also. I'm just trying to find where I can find this data. So then I have another feature, which is the humidity. Okay, so humidity. Okay, humidity is where either the humidity is high, or it is, let's say, normal. I have only two classes here. So let's say on the first day it was high, on the second day also it was high, third day also maybe it was high. Okay, on the 14th day also maybe it was, let's say, high. Okay, for some days over here it was actually normal. Okay, but as you can see, I have written high or H 4 times, because I want to signify that this feature here representing humidity is more inclined towards humidity being high as opposed to humidity being into a normal range. And then the third variable is the wind speed. Okay, how is the wind outside? Is it really windy or is it okay? So here, in this field, I have only two kinds of variables, or I have only two kinds of data. Either the wind is weak or the wind is strong. Okay, except for the first day it is windy, second day it is strong, the third day it is weak, again it is weak. Then let's say on the 14th day it was strong, right? So in between these days we have other values also. Even in case of the play field, the play field is going to be n if they were not able to play. It is equal to y, as I have prepared the data. It is equal to y if they were able to play. Let's say on the last day they were not able to play, right? So this is my problem. I have four kids here who would like to play, and I would like to help their parents answer this question whether they should really go out to play, because it should not happen that they are going out to play and that is impacting their health. So I have the data of the last 14 days with these three features, and this is my target, right? Now, why I said the method that I'm going to use is going to be very business friendly, although this problem statement is not a business problem. But what I'm doing here is, okay, what I'm trying to do over here is I'm trying to find out, I'm trying to figure out if there is any modeling technique, if there is any machine learning technique. Actually, this technique is borrowed from the statistics world, and later it is advanced or enhanced by means of other things that we could do using computer science. So it's a technique which is borrowed from the statistic world, and this technique is usually, okay, this technique is usually uh, represented in the form of uh, the same structure which we used to see when we used to do the data structures and algorithms kind of thing. If you remember, when we used to do uh, uh, decision diagrams, we used to say, okay, I'm going to take a decision here. Then if that decision is good, and I will do this. If the decision is bad, I'm going to do that, and so on, right? So based on my data also, or based on my situation, if my data, and I'm going to explain in which conditions I'm going to use this kind of an example. So uh, basis my data, basis my situation, I can model my environment, which looks something like I'm starting from a certain point, okay, a certain circle here. This is my initial place. We have to decide how we came onto this initial place. I'm going to mark this as I. So this is my initial place. Later we are also going to mark it as R, and I will tell you what is the full form of this R. Then I'm going to decide what is the value of this initial stage that results into one of two of the categories. So I will break this I into two categories. It may be true or false. It may be based on value and so on, right? It may be based on threshold. It may be a Boolean value like true or false. So just for the simplicity's sake, let's consider this is bifurcated. This is true or false. So this is some condition which is getting fixed as true or false, right? So this is getting fixed as true or false. So now what I'm doing is here I have another circle. If this condition is true, I will do this activity. If this condition is false, I'm going to do this activity. Then again, for each of these circles, I'm going to again check for a true and false. Okay. Now, how long am I going to continue doing this? That is dependent on how many conditions I would like to check, or in other words, how many variations or how much of variation I have in my data, right? So in this case, let's say I have only this much of variation, that I can go up to 3 levels. As you can see, I have drawn 3 levels over here. So this is my first level, this is my second level, and this is my third level. And there are specific names to these labels also. But overall, if you see whatever diagram I have drawn over here, right? This diagram, okay, this structure looks like a tree, right? It is actually looking like an inverted tree. So for example, if I would have drawn a very simple drawing of a tree, what we used to draw in the childhood days, the tree would look something like this, right? So I have a branch, okay, I have the root, okay, I have the root, and then I have the trunk, okay, so this is the root, this is the trunk, and then I have the branches, right? And then what I'm going to have end of the day, this is the leafy part, right? So there will be structures or figments from where my leaf is going to come out, right? So I'm going to mark that as L. Right. I can also consider the branches to be similar to the trunk because actually the branches are coming out of the trunk. But I'm going to consider these leaves or the leafy branches to be different. And in the same, let's say, methodology, what I'm going to write over here is this R, or this first cell or this first I that I have, is called the root node. I'm going to call this the root. And then all of these that come in middle part, okay, if I ignore the first part and the last part, everything else that comes in the middle part, I'm going to call them the branches. So I'm going to call them B. And whatever comes at the bottom, I'm going to call them the L. So basically, this tree-like structure, okay, this tree-like inverted tree-like structure is helping me taking a decision, right? So that's the reason why I'm going to call this algorithm, this way of solving a problem, as a decision tree. Okay, so this is an algorithm which we commonly known as a decision tree. So here what we are doing, we are representing our problem statement in form of an inverted tree, and we are going to take a decision basis that problem, okay, or basis the model that we have created, right? So each and every of these cells, okay, the cells that I've drawn over here, each and every of these cells can be called A, and A can represent attributes. Okay, attributes are what? Attributes are actually the features. Okay, the features that I am drawing. Okay, the features that I have in my data also. If you look at my data, I have some features in my data also. So I'm going to consider these features are actually going to be consistent, or actually going to be consisted within the tree, right? So wherever I have written A, even this part is also A. Okay, so this is, I can replace that I now with A, and that initial branch, or that initial root phase, is also an attribute which is there in my data. And each branch, okay, each branch that I have over here, like this one, and so on, each of the branch is representing an outcome of a test that I've performed here, right? So I've performed a test whether this attribute A is true or false, and then I came to these two conclusions, right? If it is true, then I came here. If it is false, I came over here, and so on, right? In the same way, I'm actually traversing in the inverse direction of an actual tree. Okay, I'm traversing in the inverse direction of an actual tree, right? This technique of traversing this tree, if I put this into a logical format, is going to give me an algorithm which is otherwise known as a decision tree. And that tree is going to help me take the decisions. But I have to be very careful because there are some things which are very tricky here, and some things which I have to mathematically solve. The first and the foremost thing that I have to mathematically solve over here is a very, very big question. And for that, we are going to use serious math. So this is a question other than the business question. I'm not trying to consider the business question. My implementation also has a few questions. The first question is that how do I know, okay, how do I know what is going to be my root node? Okay, from where am I going to start doing the breakup? And then how do I decide, okay, how do I decide how to break them into branches and then ultimately into leaves? Also also I need to know another important thing. I need to know what is going to be, okay, what is going to be the depth of my tree. So what is going to be my I, which is my initial cell of the tree, or the root node of the tree, and what is going to be the depth of my tree, how many I'm going to break. Now, if let's say I have a simple situation like true and false, it's fine, I can break this into two parts, that's okay, it's good. But what if I have numeric values? So for example, this A field is not actually a categorical variable, it's a continuous variable. In this case, the value can range from minus infinity to plus infinity, right? Then how am I going to break this into this kind of a structure? I have to create some rules, right? So for example, if the value is less than zero, that's one, let's say, category. So I'm just going to remove this. So let's say value of A, okay, this A is less than zero, that is one a category. Value is in the range of, let's say, 0 to 5, that is a category. And in this case, that will be value is in the range of minus infinity to 0. And then I have another range, let's say the value of V is within the range of 5 to plus infinity. Okay, so these are the three ranges in which I can break it, and then I can create as many number of branches as I want. So instead of two, I can also have three branches, four branches, and so on. So four uh, conditional statements basis which I'm going to break them. So if you consider this, or if you try to find an analogy of what what is actually happening over here. This is similar to the if else statements which we have written in Python, right? So if this condition is to do this, if not then this, then else if, and so on and so forth, and ultimately your if else loop is going to end, right? So in the same way, I'm representing my business problem or any such kind of a scenario which I have over here, which is children playing, into a scenario, into a tree like structure, which is this, using maths like this. And then uh, I'm going to prepare my data. I'll have to decide from where to start. I have to decide how much to go, and so on and so forth. Because usually the reason why I was taking this continuous variable example is because for the categorical fields, it becomes quite easy for me to limit myself up to what point in time I'm going to go in, right? But for continuous variables, it is always really very difficult to understand where I'm going to really stop. Okay, what is going to be the depth of my tree, right? Okay, I hope until this point the concept is clear. Or are there any doubts?
Yeah, no doubts.
Okay,
No
okay,
doubt.
okay. So now what we are going to do is that using this example, we are going to draw the diagrams, or maybe I can even draw it in an Excel sheet. That would have been better. So let me do one thing. Let me do this in an Excel. Okay, give me 2 minutes. I'll just open the Excel sheet. Give me 2 minutes. So it is really very slow today. Very sorry for this. Something has happened to my laptop. And my laptop is really very slow. I don't know why. Let me just see. Okay. Yeah, it is opening now. Okay. Give me 2 minutes. It is opening and I will share my screen. Yeah. Give me 1 minute. Yeah. Okay. I think I can share now. Yeah. Okay. I hope you can see the Excel sheet that I have here. So now what I'm going to do, I'm going to simulate the same thing, the same problem statement into my Excel sheet. And I'm going to do some calculations, which obviously I don't have to do in Python. That is the reason why I'm doing it in Excel. Okay, deliberately I'm using Excel because in Python you already know how we do the analysis things, right? I mean, it's really very easy. We just call the modules and the functions which are already created, right? And I just use that and my thing is done, right? So it is really very easy. So why not do it in an Excel sheet? And that way we will understand, right? We will understand how the things are going, right? So what I'm going to do, I'm going to create the data set first. Okay, I'm going to create the data set first. Okay, and then I'm going to carry on. So my fields were, if you remember, first field was overcast. Oh no, sorry, Outlook. Okay, Outlook has two values: overcast, rainy, sunny, three values. Okay, then my next field is what? My next feature is temperature. Okay, next field is what? Humidity. Okay, uh, let's say next field is windy. I've just introduced one more field here, which is the temperature. Okay. Then my fifth field is place. So let's say I have five now. I have another extra feature that I did not talk about earlier, but I've just added it over here. That's going to make some sense when I do the calculations. So let me just add the 14-day data over here. So what I'm going to do, I'll insert a row over here, which is just mention the day number. So 1, 2, 3, and then I'm going to drag and drop. So in Excel, you can simply drag and drop and it will fill up the cells. So now I have 14 days of data. So what I'm going to do now is that let me just make this beautiful by giving it some borders. And now I am going to write my data over here. So let's say Outlook is overcast here, overcast on the third day, fourth day. Then on the fifth day it is rainy. Then sixth rainy, seventh rainy, eighth rainy, nine rainy. then let's say sunny. Okay, then it came as sunny. Okay, sunny and sun. Okay, let's say this is the data that I have. Then in the temperature field, I'm going to have hot, cool, and mild. So let's say first day was hot, sorry, not hit, hot. Then the second day was cool, third day was mild. Okay, then again I have hot, mild, cool, cool, mild, mild. Let's say now it will be hot, hot, mild, cool, mild. Okay, so basically, as you can understand, I'm actually making up the data. This is not an actual data. I'm just trying to put some values in here so that I can explain you how things work. Now, let's say humidity can have two values, high and normal. So let's say the first day it was high, next day it has gone to normal, then again it is high, then it is normal, then it is high, then it is normal, again normal, normal. Then let's say high for 4 days, and then I have 2 days where I have, let's say, normal. Then I have the windy field. Okay, let's say windy. Is it really windy or not? So how I'm going to do that? Let's say I'm going to represent it as true and false. Okay, so I'm going to represent false when it is not windy and true when it is windy. So on the third day also, let's say it is true. Uh, I'm going to represent as F and T because otherwise this Excel sheet is behaving wrongly. So let's say I have this, let's say is false, again false, false. Then let's say this is true, again false, and true, false, true, false, false. And let's say in the last cell I have true. And then the last field, okay, did I play or did I not play? Okay, so I'm going to be a bit biased here also. I'm going to be a bit biased towards the children. So what I'm going to do, let me put yes. Okay, for the first 6 rows. So for the first 6 days, irrespective of whatsoever is the condition, they went out and played. On the seventh day, they could not play. Okay, eighth day they were able to play. Then again, no, 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 and no. So for 4 days they were not able to play. Again, they are back to normal. So if you see the count of values over here, I have how many yeses? These are 6 yes, 7, 8, 9. Okay, so out of 14, okay, out of 14, I have 9 days where actually I have played. Okay, these will be numbers which will come really handy at a later stage. Okay, and you will understand why I'm saying this. But let's say this is the data. Okay, so this is the data that I have. Now what I have to find out, what I have to figure out is that how do I select, okay, how do I select that root node, right? How do I select that node from where I'm going to start creating the tree? Because I need to select that cell first. I have to select that cell and then I can do the breaking. Okay, breaking also basis on what value, how am I going to do? This is easy because let's say if I select a temperature value, okay, then I can have 3 branches here, right? Hot, cool, and mild, hot, cool, and mild, and so on. If I would have selected humidity as the root node, I will have only 2 nodes, right? It's going to break down into 2 things because I only have high and normal, right? Or if I have selected windy, it would have been false and true, right? So I have to select one of these features. Okay, as of now, I'm going to ignore this day because this day is not going to make much of a sense right now. At a later stage, we will take more examples where this day number might make sense. Okay, in this example, we are most interested to look into these. Oh, I'm sorry, to look into these, right? So we are more interested in column B until column E, right? So to find, okay, to find the the best place, okay, the best place from where I can break things, okay, from where I can break things and I can continue doing things is where is going to be driven, okay, it is going to be driven by a fundamental concept, okay, a fundamental concept which is otherwise known as entropy. Okay, I'm going to write them: entropy and information gain. Okay, these are actually terms which belong to statistics, right? These are terms which actually belong to statistics, but we are going to make use of them. Okay, we are going to make use of them in our case. Okay, we are going to make use of them in our case in the right way. Okay, now Information gain is what? Let's try to define these terms and then we will continue. Okay. Maybe we wouldn't have time to code for today. So give me 1 minute. Let me just close these windows because we are not anyways coding. So it will go into conceptual things only for today. So let me just close my unnecessary windows because I see that my laptop is getting slow. So why to make it slow? Let me close them and then we will continue with code from the next day. So I'm going to share all these things. So please don't worry about that. As of now, let's try to understand what are these concepts. Okay. So to better explain these concepts, let me do one thing. What I'm going to do, I'm going to take uh, Notepad plus plus application and I'm going to share that with all of you and I'm going to start writing things over there. So the two concepts that I was talking about, one is entropy, another is information gain. So I'll start with information gain because information gain is from where we relate to entropy, or vice versa. We can do in the opposite way also. But information gain is actually the positive thing. So why to start with a negative thing? Let's start with a positive thing first. And then we are going to go ahead and look into the negative thing. So information gain is what? In statistical terminology, information gain is nothing but it is a measure, okay, of facts. Okay, we are simply going to measure some facts. Something has happened and we are going to measure it. Now the question is how and why are we going to measure it? How? I'm going to show that to you using that Excel sheet. But why I'm going to measure it? Okay, why I'm going to measure it is because I would like to know, okay, the ratio of factual information or actual information as as opposed to the uncertain information, right? I would like to take a metric, or I would like to create a metric. I would like to define a KPI, a key performance indicator, which is going to tell me in my model or in my analysis that I'm trying to do how much, okay, how much is the actual significance, okay, or how much is the actual information that I can gain out of my model, okay, uh, as opposed to how much is my uncertainty, how much I could not explain, right? So you can consider this analogous to R square value. If you remember R square value from our linear regression side of things, so R square value being more closer to 1 is a good thing, right? It will never be equal to 1, but more it is closer to 1, it is really good. It falls in the range of 0 to 1. The closer it is to 0, we have a very bad thing. So for example, if R square value is 0.73, then I can say that my model was able to explain what? 73%, okay? 73% of the variation in my data. So 73% of factual information I was able to cover, as opposed to the rest 27%, which is uncertain. I don't know. I don't know about the rest 27%. Okay. So in the same way, R square is not a value, by the way, which we are going to use over here. It is just an example which I took to make you understand. Now, in the same way, information gain is where we will try to find a ratio between factual information and the uncertain info. This is going to tell us how good my data is or how good my analysis is. Okay. Now, clearly, if I'm able to find this out, my intention is to focus more on how good my model is. And that is the reason why information, again, I can say that it signifies, okay, I can say it signifies the reduction in uncertainty. Okay. It helps to reduce, it helps to signify the reduction in my uncertainty. And that uncertainty of my model or my choices that I make is going to be defined by the entropy measure. So entropy is actually the measure of uncertainty. Okay, entropy is the measure of uncertainty. Okay, in our context, okay, in the context, I'm not going to write anything more on entropy because it is just the measure of uncertainty. We are going to find out how we actually find out the measure, or this measure can be actually calculated. We are going to do that in Excel. But in our context, in case of a decision tree that we are trying to make, And what that decision tree is doing is, let me just cut this and go over here. So what this decision tree is doing is, this is a inverted tree like structure where we where uh, we take decisions based on the tree we result in creating or forming. So we create a tree, and basis the tree we are going to take some kind of, it's a decision basis the business problem we have. Now clearly we will have to decide, as we discussed, we'll have to decide which or how to select the root node, and then we have to also decide what's going to be the depth of the tree. Okay, so to understand and also to better understand the model and to answer above questions, okay, we make use of information gain and entropy measures. Okay, we can assume that these are simply KPIs of my uh, final outcome or the model that I'm creating. Okay, so how good or how bad my model is, or how good or how bad the decisions that I have taken, will be actually centered around the concepts of information gain and entropy. Right, now what we are going to do in our context, okay, in our context, what we do is, in our context, we use, in this context I should write, in this context, okay, we use entropy and information gain, okay, gain to measure, okay, this is a very important term which I'm going to introduce now, purity. Okay, the purity of a node. Okay, I'm going to understand the purity of a node. For each and every node I will have information gain. For each and every node I will have the entropy value. The value will be calculated overall as well as for each and every node, and that, okay, is going to tell me, okay, that is going to tell me, that would help me to split, right, and that would help me to split each node into branches. Okay, branches, sorry, branches, until until we reach, sorry, until we reach the leaf stage. Okay, we have to reach the leaf stage. So until we reach the leaf stage, okay, information gain and entropy is going to help us understand how good or how bad my model is. Okay, the next thing uh, that we have to always remember, the most important thing here, this is really not, or this should not really be a surprise. So what our objective here is, our tree, or our objective here, okay, is that using this decision tree, we are going to find we are going to find, so I'm going to write, decision tree is all about finding the attributes or attributes, okay, um, which has highest information gain. Okay, I'm going to write information gain as IG so that I can just save some space. Okay, now there are some uh, softwares, okay, some statistical softwares like R, right? For example, if we were learning data science using R creates a decision tree by automatically considering this factor. Okay, there are few libraries in Python also which will automatically take care of this. Fortunately, sklearn is one of them. So sklearn as of date, scikit-learn has as of date evolved to that stage that it can take care of this automatically. So we don't really have to do the calculations, but we need to know what are these calculations. And that is the reason why we need to know what is an information gain and what is going to be uh, uh, the value of the entropy. Okay, so let me get back to my Excel sheet. I hope until this point it was clear. If you have any questions, please do stop me. Yeah. So I'll just remove these two from here because we are going to calculate them anyways. So let me calculate. Okay. So first of all, what I'm going to find out. Okay, what I'm going to find out is that uh, what are my unique fields. So for Outlook, I have three unique fields. Okay, I have three unique fields. So I'll just take a copy of this and I'm going to put it over here. Okay, so this is my Outlook. Okay, and then I have what temperature. Okay, for the temperature, I have hot, yeah, hot, cool, mild. Okay, for humidity, I have high and normal. Humidity, I have high, uh, normal. Then I have the windy thing, the windy variable, which can either be true or false. And then I have the final outcome, which is play. Okay, so play I have yes and no. How many? I'm just going to cut this over here and I'm going to put it over here. For play, how many yes? How many total rows do we have? We have total 14 days of data, so we have 14 rows. And yes value is what? 9. And there are 5 cases where I have no, right? Let me just quickly confirm. These are the 4 no's and 1 no. So I have 5 no's. Everything else is yes. So no is 5. So this has to be 9, right? Now, what I would do is that, mm, okay. Now, how I'm going to select, okay, the first variable, the initial root node. How I do that is, let's say, okay, let's say I'm going to select Outlook. Okay, if I select Outlook and if I select one value, which is overcast, okay, if I select only overcast, so what I will do now is that I'm going to use this data tab over here. I'm going to do a filter and I'm going to select only overcast. If I select only overcast, okay, what is happening to play? See, everything is yes. I have 4 instances of overcast in my data, right? And everything is yes. Okay, so when Outlook is equal to overcast, I have all play options equal to one value. Now let's change this to rainy. If I change this to rainy, I have 3 yes and 2 no. I have 3 yes and 2 no. And if I change this to sunny, okay, I have 3 no and 2 yes, right? So in only one of the cases, which is overcast, I have all the values of the target variable, which is otherwise known as, in statistical term, a pure subset, which means it has purity to the maximum level. It means it has a very good information gain. I'm going to derive the formula of the information gain also, but overall, this is the concept of information gain. If I select Outlook as overcast, right? If I select Outlook value as overcast, I get all the outcomes of play is equal to yes, which means this is a very good node to decide my outcome factor. Or this feature Outlook having a value overcast is actually a very good indicator of what is going to be my outcome. In this case, I may not even need a machine learning model. It is very clear from my historical data. Whenever I have Outlook equal to overcast, I've always played, which means if the Outlook is overcast, I can happily let my children go outside, right? Which means this value of this field Outlook, this value is equal to overcast of this field Outlook, is actually a very pure subset node, or it is resulting, okay, into a pure subset node. The pure subset is what? A subset which contains only one type of values, right? Why are we talking about this pure subset thing? Is because we will create the root node using such an attribute, okay, which helps us break my data into pure as well as impure nodes. Okay, so I will have pure as well as impure nodes, pure and impure nodes, and I will continue breaking these impure nodes until I get a pure node. So now I have answered at least one of my questions clearly: how much depth I need. I need a depth of the tree where I no longer have any impure nodes. Impure node means what? The example which we saw. So let's change this. Let's change overcast to rainy. Why am I going to call this an impure node? Because I have 3 instances of yes and 2 instances of no. So if I only consider outlook as a feature and I forget temperature, humidity, and windy for a time being, outlook being equal to rainy does not signify whether I can play or I cannot play, because 3 out of 5 times I have played, 2 out of 5 times I have not played. So I'm going to be confused if this value is there. So that's why this is impurity. This is the sign of impurity. The information gain is not good. I cannot say it is bad. I can only say it is not good. It is not as good as when I took the example of outlook being equal to overcast, because for overcast everything is pure. So that becomes my pure node, and whatsoever is my impure node is going to be the rest of the two. So what I mean by that is, in this diagram, in this context, okay, in this diagram, let me just clear this. If I take outlook as my root node, I have 3 values in which I can break it, right? I have overcast, I have rainy, and I have sunny, if I'm not wrong, right? I have overcast, rainy, and I have sunny. In case of overcast, I get a pure node. I get a pure node because for when outlook is overcast, everything is yes, right? Every day I have played. But when it is rainy, it is like 3 by 2. Okay, so I have 3 days, 3 by 5, I'm sorry. 3 out of 5 days I have played. When it is sunny, it is 2 out of 5 days that I've played, right? Then I have to continue breaking this node using something else, some other feature I'll have to use. And I have to break this node also into at least 2 parts, or maybe even 3, until unless I reach the leaf nodes, or a set of leaf nodes where all the leaf nodes are entirely pure. I have to remove the impurity. In many practical problems, we wouldn't be able to remove the impurity 100%. That is impossible. Okay, that may really be impossible, but that is the idea, that is the intention which we are trying to do. This is a very simplistic example. This is because this is a very simplistic example, we will actually arrive at a point. We may, I mean, let's try it out. We may actually arrive at a point where we will not have any impure nodes. How? Let's see. Let's use my eraser. Let's remove this part over here and let's remove this. Now, I have blatantly considered outlook. I have not done any mathematics. You have to do some math. So without doing any math, I have taken outlook, and then I have broken it into overcast, rainy, and sunny. Overcast I can ignore as of now because it is completely pure. Okay, so let us ignore it. What is left is, it's a sunny. Okay, if I have sunny, let's try to take another feature and let's try to see what happens in case of, let's say, sunny. So I'm going to select sunny and I'm going to take any other feature. Okay, any other feature to understand how I can make this node a pure node. You can clearly see the answer on my screen. Okay, you can clearly see the answer on my screen is humidity. For humidity being high, I have never played. For humidity being a normal, I have always played. So humidity high means I'm not going to play. So I'm going to break this into 2 parts. And now my variable, okay, my variable, I'm no longer going to write 2,5. I'm going to write the variable basis which I'm breaking it. I'm taking humidity and I'm breaking it whether humidity is high or it is normal. I have only 2 values of humidity. See, it can either be high or it can be normal. When humidity is high, humidity, I'm going to write this as HU. So when humidity is high, I have never played. So my answer is a pure node where I have never played. So no, this is not a probability sign, friends. Okay, this is just a pure node and all my answers are no. Again, for no, I have a pure node where all my answers, okay, all my answers are yes, right? So I have reached one stage where I have what? 4 nodes now, 4 leaf nodes now. In the iteration 2, I have reached 4 nodes now where 3 of them are pure and 1 of them is still impure. Let's try to see if I can do anything about this node. So what I'm going to do, let me just take the eraser and remove these things from here. And then I'm going to find out my next variable. What is going to be my next variable? I have rain. Okay, I have rain, which I have to solve. So let's just select rain over here, and let's see if there are any patterns in the data. Because this is a very simple example, I can clearly go ahead with the patterns in the data and I'm able to solve the problem. Okay, let's see if there is any pattern here. Okay, let's see if there is any pattern here. If there is rain, then do I have any pattern? I can see a pattern already in my data. I can see the pattern here already. So I'm going to apply the pattern here. I hope you have already seen it by now, but I'm going to explain it also. I'm going to take the pattern, okay, or the variable here as windy. I'm going to take wind, okay, windy as the factor, because every time windy is false, I have played, you see. And every time windy is true, I have not played, right? So if windy can be true or false, here I know it has two values. So let me just break it into true. It can be true, it can be false. If windy is true, okay, I'm not going to play. So this is a pure node. Answer is no. I will not play. This is also pure node. Answer is yes. I'm going to play. Now you see, I have 5 leaf nodes. Every one of them are pure. This is the stage where I stop. I stop my execution because I have got all the leaf nodes as pure nodes and my decision tree is ready. Okay, this is how you create a decision tree. This is how we are going to use the mathematics that we are going to learn in the next class. We'll see the mathematics, we'll see how we are going to calculate information gain and entropy and so on, because life will not be as easy as this example, right? So we need to know what is the information gain, what is the entropy. We're going to take that example and we will try to solve this problem also. The answer is going to be the same, by the way. Okay, so the answer is going to be the same. So we will break that. We will break our problem into in this way. You will come to know how it is getting broken, and then we are going to arrive at the same decision tree. If you do the calculations also, you will come at the same tree. The reason why I did it in this way, so that I can first of all make you understand how the tree is going to work, how we are going to actually create a tree, or how our algorithms are Python libraries are going to do it. Internally, they are going to do some math. So that we are going to do tomorrow, but this is the objective. I have got my tree which is going to give me the decision. The decision is simple. If outlook is overcast, I will play. Okay, clear cut answer. If outlook is rainy, I will see what is the wind. Okay, is it windy or is it not windy? If it is windy, okay, then I will not play. If it is not windy, I'm going to play. If the outlook however is sunny, I'm going to check what is the humidity. Is the humidity high or is the humidity normal? If the humidity is high, I'm not going to play. If the humidity is normal, I'm going to play. So I have answered my question. When can I play and when can I not play? Simple. I have answered my question. Okay. So based on what is going to be the situation on day number 15th or day number 22nd, I'm going to take a decision basis this model. Okay. This is my final model. I'll take a decision based on this model, what I am going to do. Right. I hope there are no questions. Please let me know if there are any questions right now.
So, Bhomik, so
Yeah.
temperature was not useful in this.
Let me just go back. Yeah, it seems yes, you are right. Temperature was not really useful in this, because if you look at any other feature, I mean, if you only look at, let me just remove the filter over here. If I just do a filter on the temperature value only, okay, it has a lot of impurity, it seems. For example, if I select cool, I have a division of 3 to 1. Okay, so 3 by 4 and 1 by 4. If I select hot, I have 2 by 4 and 2 by 4. Okay, so 50% chance I'm going to play, not play. Then if I select mild, okay, then also I have 4 by 6 and 2 by 6. So everything that temperature is resulting into is impure. And that is the reason why I have not considered the temperature value at all. So most probably I can either drop this field after my model is created, or during the model creation stage only, this is not going to be used. But that's a good point. Sometimes what we do, we check for the patterns if the data is really this simple, and if we are able to check the patterns, we can find out the information gain and the entropy ourselves, and we can decide if we are going to keep that column or not. Okay, but trust me, current date algorithms are so strong, they will identify this by means of information gain only. Okay, looking at the patterns in the data, looking at information gain and entropy value, they will themselves come to know, no, boss, this field is of no value. Let's not consider it while we are doing the model.
Okay. Okay.
Any other questions?
Not from
Uh,
my book.
okay. Okay, then, friends, let's make a call then, or let's make an end now. We will continue tomorrow, and what we will do tomorrow is that again we will go back to Excel sheet. We will calculate entropy and the information gain using probability. So, just a hint: if you would like to read how entropy and information gain is actually counted, it's counted basis pure, very simple probability, and on top of that it is counted on basis of, or it is calculated on basis of conditional probability. So if you would like to revise the concepts of conditional probability, this is a good time. Okay, because from tomorrow I'll implement those functions of conditional probability in my Excel sheet, and I'll find out the information gain and the entropy values. It is also going to tell me, okay, the same thing, okay, that I have already found out. Okay, I hope that is fine. Then let's make a close here, friends. Thank you so much for joining.
Thank
Thank
you,
you.
Bhamik. Good night.
Thank you, Bhaumik. Good night.
Thank you.